Okay, welcome back, students. Okay, in the last video, we showed you how to expand brackets. Here we're going to do the same thing. We're going to expand the brackets, but after we've done that, we're going to have to go back and add and subtract like terms. So this is called expand and simplify. Oh, by the way, the rule when you expand brackets like this is actually called using the distributive law. So that actually has a name. I should have mentioned that earlier. Okay, let's get started on this question just here. I might do the first one and let you have a go at the next two because they're all pretty much done the same way. So the first thing I have to do is expand the first set of brackets. 3 times all of z plus 6 is 3z plus, and 3 times 6 is 18 plus, and 2 times z is 2z minus, again, I can change that to plus negative. In fact, I might even do that in this case. Probably don't really have to. And then I'm going to end up with plus, because I changed that to a plus, and 2 times negative 3 is negative 6. So if you change all of your subtractions to plus negatives, then you're only ever going to have to add integers, and you'll never have to subtract them. Okay, let's go ahead and add the like terms. Well, here I have a 3z, here I have a 2z. They have the same variable raised to the same power, which is just 1. So 3z plus 2z is 5z. And plus, and I've got plus 18 plus negative 6. Well, 18 plus negative 6 is positive 12. So final answer, 5z plus 12. So basic idea here, expand the brackets, and then add like terms. Okay, little hint on this one, because you got a negative sign there, definitely change that subtraction to add the negative, and don't forget that there's a 1 in front of the z. Okay, away you go. Okay, welcome back, students. Let's go ahead and expand and then simplify. So once again, we need to multiply the term outside the brackets by each of the terms inside. Negative 2 times 4 is negative 8. I'm going to change that to plus negative. Oh, sorry, and I should have done the y squared before I forget. So negative 8y squared. I've changed that to a plus. Negative 2y times negative 1z. Well, negative 2 times negative 1 is positive 2, or just 2. Y times z. And then plus 5y. Just copy the rest of it. Okay, let's look at simplifying. Well, this one has y squared as the letter part. This one has y times z, and that one has just y. Well, none of these are like terms. None of them have the same variable raised to the same power. So that's as simple as you can make it. Okay, looking at the last one. Once again, probably don't need to do it in this case, but I'll change that to plus negative just to be consistent. And first, I just copy this first term down. There's nothing to do with it quite yet. So 2pq plus 2q times 3p. 2 times 3 is 6. Q times p, written alphabetically, is pq plus, and we have 2 times negative 5 is negative 10 times q. Okay, let's have a look and see if we can do any simplifying. Well, I've got a PQ there and a PQ there, so those two terms are like terms, and they can be added. 2 plus 6 is 8, PQ, and plus negative 10Q can also be written as subtract 10Q, and that's that first expanded and then simplified. And once again, we can't go any further because these are not like terms. The letter parts are different. So that's as simple as we can write it. Okay, I'd like you to have a go at these three, a bit more practice. Now, with these, you also need to change the subtraction in between the brackets to plus negative. So there, and also do it inside the brackets. So that these are a little bit harder because you're working with more negative numbers. Okay, so have a go, please. Okay, let's go ahead and start by expanding. I better change that one to plus negative to be consistent. So I've got to multiply those two. Well, that gives me 5 times r, or 5r. Everything's going to be plus, and 5 times negative 6 is negative 30, plus negative 2 times r is negative 2r, plus negative 2 times 1 is negative 2. Okay, let's have a look now how we can simplify this. I think I might get some green in here. We haven't seen green for a while. 5r plus negative 2r. Well, 5 plus negative 2 is 3, so that's 3r. Then we'll go back and get a bit of red, and we've got plus negative 30 plus negative 2. Well, negative 30 plus negative 2 is negative 32, so plus negative 32. So you can leave it like that, or if you wanted to, you could just write it as subtract 32. So change it back. So both of those are equally good. Okay, looking at the next expression. So once again, I changed that to plus a negative, change that to plus a negative. I think I'll have to write it underneath to make it fit. So we expand the first set of brackets. Negative 2 times 3 is 6. P times P is P squared. Negative 2 times 4 is 8 times P, plus negative 3P times 5 is negative 15P, and plus negative 3P times negative 2P. Well, negative 3 times negative 2 is positive 6. P times P is P squared. Okay, let's have a look for some like terms. Well, here's a P squared, and there's a P squared, so they can be added together. 6P squared plus 6P squared is 12P squared, plus, and we have 8P plus negative 15P. Well, they're like terms because the letter parts are the same. 8 plus negative 15 is negative 7. So that gives us negative 7P. Or again, if you wish to, you can write that as subtract 7P. Because the powers are different, these aren't like terms, and that's the final answer. Okay, now this one I put as many negative signs and subtraction signs into it as I can, so let's see how you went on this one. So change that to add the negative, change that to add negative 1, and change that to add the negative. I'll just make that a little bit easier to see, hopefully. So I put a 1 in front of the y, I change that to a plus, and I change the 1 to a negative 1. Okay, let's go ahead and do the expansion. So we have negative 2y times 6 is negative 12y, plus negative 2y times negative 3y. Negative times negative is positive, and y times y is y squared, plus negative 1y times 4 is negative 4y, plus negative 1y times negative 2y. Negative times negative is positive. 1 times 2 is 2. And y times y is y squared. Okay, once again, we have to look for like terms. Usually in algebra, we like to use the terms with the highest powers first. You don't have to, but that's, again, a convention. So we have 6y squared plus 2y squared. That's going to give us, I could probably write it over here, that's going to give us 8y squared. And we have some more like terms, negative 12y plus negative 4y. Well, negative 12 plus negative 4 is negative 16, so plus negative 16y. And once again, if you wish to, you can write that as 8y squared subtract 16y. So if you can do questions like this consistently, then you know how to expand, and you know how to expand and simplify. I think we have one more page to go. Maths textbooks love areas of rectangles when they're teaching this because it's sort of a practical application. So let's go ahead and try this. A rectangle has a width of 2a meters, which is just there, and a length of 3a minus 3b meters. That should be 3a minus 2b based on what's in the diagram. So it has a length of 3a minus 2b meters. Write the expression for the area and expand the brackets. Well, you need to remember from measurement that the area of a rectangle is length times width. So I can write area equals, and I could write that times that, but normally we like to write the single term first and not the addition or subtraction. So I'm going to write the width first. So I'm going to write the 2a multiplied by, we don't show the multiply in algebra, and we write the length, which is 3a minus 2b. So there's the area written as in factored form. Let's go ahead and expand it the way we learned how to do in previous pages. So 2a times 3a, well, 2 times 3 is 6. A times a is a squared. I'm going to keep that as a subtract in this case. 2a times 2b is 4ab. So there's the answer in factored form, and there's the answer in expanded form. Okay, what we're going to learn in the last video in this chapter is how to go backwards. So if an expression is given to you in expanded form, how do you then turn it back into the expression in factored form?